Hello, and welcome to the final project presentation for CIDM 6355 data mining. The group is Serafat Aramu, Tosh Jr., and Brian Reddick, and we will walk through our final project. A software company sells tutoring software to large educational institutions and private individuals. And this project takes sample output data that is gathered during the tutorial process and tries to predict if we can, based on a set of attributes, determine if a student will provide a correct answer. Essentially, we want to uh, measure the effectiveness of the tutoring and also optimize the tutoring software. And we plan to use data mining to do that. So overall, what's the business problem that we're trying to solve? Well, what we're trying to do is maximize student success by optimizing the tutorial model that we use in the software, while simultaneously not making the tutorial and the test questions so easy that it's difficult to tell if the student is actually learning. Different attributes related to the tutorial can be adjusted in order to provide a different experience for the student, and thus it is critical that the tutorial provide a mix of challenge to the student while simultaneously providing support, assistance, and hints, but not making it too easy to answer the questions. Ultimately, given the attributes associated with the tutorial data, the company would like to be able to predict the probability of the student correctly answering a test question properly the first time. If we can create challenging software that allows the student to be supported and yet still solve math problems while not making it too easy, we can really maximize profit by creating a large demand for this software due to its quality and effectiveness. Tactically, we had to ask ourselves a couple of questions. One, are multiple models as we use our data mining techniques appropriate to use? Can we use naive Bayes? Can we use decision tree, for example? And are they mutually exclusive? And if we can use multiple models, which model is the best predictor of student success? Now, the data takes the form of records of interactions between students and computer-aided tutoring system, and it consists of transactional records captured by the tutorial software of students who took an algebra tutorial between 2005 and 2007. The students solve problems in the tutor, and then each interaction between the student and the computer is logged as a transaction. There are about 10 million records, and they have several attributes associated with each record. Some of them include things like student ID, the tutorial start time, how long the entire transaction took between the time that the tutorial started and the time the tutorial ends, how many times the question was answered or problem was answered correctly the first time, how many hints did the student request, and several other pieces of data that will indicate how effective our tutorial actually is. Generally, the tutorial process is pretty straightforward. The student first registers on a website with an account in order to be able to access the tutorials. Once they've registered, they choose a tutorial or a tutorial subject, geometry, algebra, trigonometry, for example. And once they've selected a tutorial and a subject, they are presented with a set of lectures and instructional slides to read in order to learn about that subject. Once the instruction and the lecture period is over, the student is then presented with a math problem. The unique challenge is that the math problem is actually presented as a set of steps. So for example, one algebra problem may have a set of equations where you have to solve one equation by solving for x and then substituting that value into a second equation, substituting the value that you find of x into the second equation. So that step one would be recorded as a transaction where the student has to solve for x. The second step would additionally be solved and recorded as a second transaction and tracked separately. So there would be two separate records for each step. Once all of the steps for that particular problem are correctly solved, the problem overall is considered solved, and then summary data related to that student's success and experience with that particular tutorial is generated. To make that more clear, this slide is a more detailed outline of the steps that a student goes through when they take the tutorial, and also the different sets of data attributes that are generated along the way. So you can see in the first step, the student registers, and so the attribute that is created in that record at that point is a student ID. Once the student registers, they select a tutorial, and so we have then captured as an attribute the tutorial name. Once the tutorial has been selected, the instruction actually begins, and we collect the time that the tutorial itself started. The tutorial and the instruction goes through, and once the instruction is completed, the tutorial then presents a test problem to the student to solve. And the problem, again, is presented in multiple steps. So the first attribute that we record at that point is the first transaction time, or the first step time, also known as. If the student completes that step incorrectly, the step is represented to the student along with some feedback on things they should have studied or concepts that they should have learned that may help them solve the problem correctly the second time. At any point during this process, a student may ask for a hint. And so at that point, we also collect the number of hints and the number of incorrects that a student may have collected through the course of going through this process. If the second or third time, or even the fourth time, the student actually solves the step correctly, then we collect the amount of time it took between the first transaction and the time it took for the student to actually provide a correct answer. We collect if the student answered the question correctly on the first attempt, and we also capture again the number of hints total that the student may have asked for. Once all of those steps are completed, the problem overall is considered complete, and the tutorial itself concludes. Once the tutorial concludes, or at least that module, summary data related to that module is then collected. For example, the overall duration from the start time to the finish time of the problem, if there was an incorrect step along the way or a series of incorrect steps, we track how long it took between the time that the student started the tutorial, they answered the problem incorrectly, and the time that they actually answered the question correctly. We also collect the number of hints again and the number of corrects, the number of times that they have correctly answered a set of problems. And a student may be presented more than one problem in a tutorial. And so there may be multiple steps created due to multiple problems being generated and created to the student, depending on the complexity and difficulty of the tutorial itself.